Ever wondered how an aircraft maintains a straight and level flight without changing speed or direction? Let's delve into the basics and answer that question for you. Firstly, it's crucial to understand that during horizontal straight flight, the aircraft is in equilibrium. This means that all the forces acting upon it are balanced, resulting in no resultant force that could alter its state. You might be wondering, what does equilibrium in flight really mean? Well, acceleration represents an increase in speed or a change in direction, or both. In horizontal straight flight, the aircraft isn't compelled to alter either its speed or direction. This is because the forces acting on the aircraft are in perfect balance, maintaining the aircraft's state of equilibrium. So, what are these forces? There are 4 primary forces acting on an aircraft: lift, weight, thrust, and drag. Each of these forces has its own point of action and role to play. Lift is created by the air pressure difference on the upper and lower surfaces of the wings. It acts upward through the aircraft's center of pressure. Weight, on the other hand, is the force of gravity acting downward through the aircraft's center of gravity. Thrust is the force that propels the aircraft forward in flight. It acts in the direction of flight. Opposing the thrust is drag, which is the resistance to forward motion and acts in the direction opposite to flight. In a condition of equilibrium where the aircraft achieves horizontal straight flight, lift equals weight and thrust equals drag. That is, the upward force of lift balances the downward force of weight, and the forward force of thrust balances the backward force of drag. So, in a nutshell, for an aircraft to achieve horizontal straight flight, lift must equal weight and thrust must equal drag. It's a delicate balancing act that keeps the aircraft steady in the skies, creating the magic of flight we often take for granted. But where exactly do these forces act on the aircraft, you might ask? Well, each of the 4 primary forces acting on an aircraft has its own unique point of action. Let's delve into each one. First, we have lift. This force acts through what we call the center of pressure. You can think of this as the focal point of all the lifting forces acting on the wings. It's a bit of a moving target, shifting around depending on the aircraft's attitude and speed, but it's always there, keeping the plane aloft. Next, there's weight. This force acts through the center of gravity. This is the point where all of the aircraft's weight is concentrated. It's like the balancing point of a seesaw. And just like lift, the center of gravity can also shift, especially when fuel is consumed or if passengers or cargo move around. Then we have thrust and drag, those opposing forces that propel the aircraft forward or hold it back. They act in opposite directions, parallel to the flight direction. The points of action for these forces can also vary with the aircraft's attitude and design. Usually the point of action for thrust is along the line of the propeller's axis, pushing the aircraft forward. Finally, we have drag. This is the resistance the aircraft faces as it moves through the air. It acts in the opposite direction to thrust, trying to slow the aircraft down. The point of action for drag is often somewhere along the aircraft's longitudinal axis. So you see, these points of action for each force are not fixed. They can shift and move depending on a variety of factors, including the aircraft's design, attitude, speed, and even the distribution of weight inside the aircraft. But no matter where they move, these forces are always at work, interacting with each other to keep the aircraft balanced and flying straight. Understanding these points of action is crucial to maintaining balance in flight. So next time you're soaring through the skies, remember these points and appreciate the delicate dance of forces that makes flight possible. But what happens when the center of pressure and center of gravity shift positions? Quite a lot, actually. These shifts can significantly impact the aircraft's attitude and flight path. Let's delve into the concept of moments of pitch. In flight, the center of pressure, or CP, and the center of gravity, or CG, are never stationary. They move and shift due to changes in the angle of attack, fuel consumption, passenger movement, and cargo shifts. This movement creates a fascinating dynamic that can cause a moment about the transverse axis. Picture this. When the aircraft's lift acts behind the center of gravity, it results in a nose-up attitude. This is because the combination of lift and weight creates a couple or a pair of forces acting in opposite directions, causing the aircraft to pitch upwards. On the flip side, if the lift acts in front of the center of gravity, it results in a nose-down attitude. Now let's talk about thrust and drag. These two forces also create a couple. However, the effect of this couple depends on the position of the thrust line relative to the drag line. Typically, the thrust line is below the drag line, creating an upward pitching moment. But if the thrust line is above the drag line, it creates a downward pitching moment. It's like a dance between forces, with each movement causing a shift in the aircraft's attitude. Understanding these moments of pitch is crucial for pilots, as it allows them to predict and control the aircraft's behavior during flight. Remember, these moments aren't just theoretical, they're very real and have practical implications in the world of aviation. Every time a pilot maneuvers an aircraft, they're managing these moments of pitch, using their skills and knowledge to maintain control and ensure a safe and smooth flight. These moments of pitch are integral to maneuvering an aircraft in flight. And that, dear listeners, is the art and science of aviation in action. How do these moments balance out for a horizontal straight flight? Let's dive right in. In a perfect world, the lift-weight couple and the thrust-drag couple would counteract each other during horizontal straight flight. This balance would prevent any residual moment that has the potential to pitch the aircraft up or down. However, we don't live in a perfect world, and this ideal balance among the four forces rarely exists in practice. This is where the aircraft's horizontal stabilizer comes into play. It steps up to the challenge, producing a balancing force that helps maintain the equilibrium. This balancing force can either be upward or downward, depending on the relationship between the descending lift-weight couple and the ascending thrust-drag couple at any given moment. Imagine a seesaw. On one end, you have the lift-weight couple, and on the other end, you have the thrust-drag couple. The horizontal stabilizer acts as the person in the middle, adjusting its weight to keep the seesaw level. But why is this balance so vital? Well, without it, the plane would constantly be pitching up or down, making for a very uncomfortable and potentially dangerous flight. By counteracting these moments, the aircraft can maintain a smooth, straight flight, much to the relief of the passengers and crew on board. Now, it's important to remember that this balancing act isn't static. It's a dynamic process that's continuously adjusting to the changing forces during flight. As the lift-weight and thrust-drag couples vary, the horizontal stabilizer must adapt its balancing force accordingly. It's a bit like a dance, with each partner responding to the other's movements to keep the whole performance flowing smoothly. So next time you're on a flight and you're marveling at the smooth, straight journey through the clouds, spare a thought for the complex interplay of forces that's making it all possible. And perhaps give a silent nod of appreciation to the unsung hero of the show, the horizontal stabilizer. So the counteracting moments and the balancing force from the horizontal stabilizer ensure a smooth, straight flight. So how do all these concepts come together in the real world of flying? Let's take a moment to bring it all together. We've learned that in horizontal straight flight, an airplane is in equilibrium with the four main forces acting upon it: lift, weight, thrust and drag. Each of these forces has its point of action, and they work together to keep the aircraft in balance. Lift equals weight and thrust equals drag. It's a simple equation, but it's the crux of maintaining a steady, straight flight. But it's not just about the forces. The moments of pitch also come into play. The position of the center of pressure and center of gravity can change depending on factors such as fuel consumption and the movement of passengers or cargo. These changes can cause the plane to tilt up or down, requiring the pilot to adjust accordingly to maintain a straight flight. In essence, the lift-weight pair and the thrust-drag pair should counter each other in horizontal straight flight. The goal is to have no residual moment that tends to tilt the aircraft either upwards or downwards. But this ideal balance is rare, and that's where the airplane's horizontal stabilizer comes in. It's designed to produce a balancing force which can be either up or down, depending on the relationship between the downward lift-weight pair and the upward thrust-drag pair. So what does this mean for the pilot in the cockpit? It means that a pilot may need to constantly apply pressure to maintain straight flight due to the shifting balance of these forces and moments. It's an ongoing dance of adjustments, a testament to the pilot's skill and understanding of the principles of flight. Remember, Understanding these principles is key to mastering the art of horizontal straight flight. It's not just about getting from point A to point B, but how you get there that truly counts. The art of flying is a delicate balance of forces and moments, a symphony of physics in action. The sky is not just a place, it's a state of mind. So take these principles to heart and let them guide you in your aviation journey.